I'll now talk about briefly. No? So the protocol, one of the protocols used for software-defined networking, which is the OpenFlow protocol. Now, again, I'm coming from the caveat that um, OpenFlow is not the only protocol used for SDN. In fact, you can already implement pre-existing protocols, no, to have SDN in your environment. Some of them, in fact, use BGP. I believe ISIS can also be used as one of them. So this is just one of the many few. Now, the reason why OpenFlow is put into highlight, it's because you can consider this a sort of like a pioneering protocol for SDN, right? So when SDN as a technology was made available for general use, no, as also a sort of like a template of sorts, alongside with it is the OpenFlow protocol. Now, what is it? The OpenFlow protocol is a multi-vendor standard defined by the Open Networking Foundation for implementing SDN in networking environments. Okay. It is the protocol, like what I have discussed in the previous part, no, as the protocol responsible for the controller communicating to your forwarding switches. It defines the interface between what's called an OpenFlow controller and an OpenFlow switch. So this is the southbound protocol used for communicating on both devices. It allows the OpenFlow controller to instruct the OpenFlow switches on how to handle incoming data packets. Now, what you're seeing here in the diagram, no, this is actually, I got this one from, although this came from NoviFlow, the NoviFlow website, this is actually a sort of like a generalized diagram on how the OpenFlow protocol is being used by an OpenFlow switch. Okay, so you might be wondering, how can we tell if a switch is an OpenFlow switch? What is this different from a Cisco switch or a Dell switch? No, normally you would be able to see in the device's datasheet. If OpenFlow is supported, then it can be considered as an OpenFlow switch. Okay, now, logically speaking, what can be found inside the OpenFlow switch are these logical components. You have there your OpenFlow channels, the group table, the meter table, and more importantly, you have your flow tables. Okay, now, in our course for SDN NFV, we go into detail the different components of what makes an OpenFlow switch work and how the different logical parts inside of it work in order to forward your packets. Okay, but what I want you guys just to understand for now is that for you to have OpenFlow, the switch that would be using this protocol should be able to support it, obviously. And also, the controller is also able to support OpenFlow as a protocol because this is the means of communication between the two. Okay? Now, the OpenFlow architecture, remember that it was launched into public alongside the SDN architecture. And having said that, you'll notice now that the OpenFlow architecture completely mirrors how an SDN architecture would also look like. So in an OpenFlow architecture, you have there your applications, you still have your control plane, and you also have your data plane. The only difference here is that in the OpenFlow architecture, instead of a generic controller, you now have the OpenFlow controller. Okay, the OpenFlow controller itself, this can come as a appliance on its own, meaning you have a physical box for it, or it can even be what's called a virtual machine, meaning that it is a software already deployed inside a server that you already have pre-existing, and you can already have your OpenFlow controller. Okay, and underneath it, you still have your forwarding switches, but it uses now the OpenFlow protocol. Okay, so Just to summarize the architecture in itself, so the OpenFlow network architecture consists of three layers still, similar to SDN. You have one or more OpenFlow virtual or physical switches. Take note of that one, virtual or physical, or it can be a mix, right? One or two OpenFlow controllers, and finally, one or more OpenFlow applications. The OpenFlow controller maintains the protocol communications channels to the switches. It maintains a logical or a local state of the OpenFlow switches. It exposes the northbound API to the OpenFlow applications. So then the northbound API can then be viewed by the applications themselves, no? To instruct the network to perform various tasks. So you'll notice that how the OpenFlow architecture, it is actually mirrored as to how you would see as the SDN architecture as well, right? I was actually going, so while the break, no, I went through some of the Q&As here. I was able to answer things if I'm not mistaken. And one of the questions there mentioned like, is it okay or is it possible for me to implement SDN using hardware or even software, virtual, or virtual switches? The answer is definitely yes, as mentioned here. You can actually use virtual switches to be as a means to forward your packet in an SDN environment. Heck, you can have everything to be software based already, meaning that the control plane is already a virtual machine and the switches are the virtual switches or V switches. So gone are the days that when you want to implement a network, you have to purchase the hardware. You have to purchase all of the hardware, in fact. If you already have pre-existing switches and the server at that, and you just want to purchase software, you can easily, in theory, implement SDN in your network. With the caveat that they support OpenFlow. Okay?